Hello and welcome back to my RC channel. I'm AndyRC and today I'm going to be building, setting up and flying the FlexRC 3-inch Komori. Now these days your average 3-inch build usually comes in at around about 130 grams dry weight, and this guy without a battery is weighing just 87 grams, so it has a weight similar to your average 2-inch or 2.5-inch model, but it can take a 3-inch propeller. Now, unfortunately, I don't have any 3-inch propellers in at the moment that can support the 11-sized motor. So I'm using these 2.8-inch propellers that came with the Leader 120, and it's still going to be bonkers on this propeller. But yes, it will take a 3-inch propeller. And I guess you could say it's trying to do what the Baby Hawk R3-inch is doing. And that is, these days, with the 3-inch class, I'm noticing that the motors are getting bigger and bigger. And of course, that means the model is getting more heavy. So the increase in performance isn't as much, and what this is doing, as well as the Baby Hawk R3-inch, is it's taking pretty much 2-inch components and sticking them on a 3-inch frame, which makes it very lightweight, and you should get a crazy performance. Well, that's the idea anyways. So let's take a look at the specs before I get onto the build. So the motors are the 1106 6000 kV motors that are found on the Emax Baby Hawk R, the 2-inch edition. And then the guts, this is the HGL RC F428 stack. This is the V2, so there's going to be a few different things in this build. So the V2 actually has the tramp protocol on it, so you can change the power and channel of your VTX through the on-screen display. But other than that, it's got 28 amp BL Halley S 4-in-1 ESCs. It's got a Omnibus F4 flight controller with Betaflight on-screen display, and then the camera up front is the HGL-RC micro CCD camera. The receiver is the FreeSky R-XSR, and again I'm doing something different. I'm going to hook up the SmartPort telemetry to the HGL-RC stack, which you do have to mess around with, by the way, because the flight controller doesn't have a dedicated SmartPort solder pad, so I'm going to have to do some remapping. But I know a lot of people are using this stack and other HGL-RC stacks as well, so maybe this will be useful. Personally, I don't tend to use these R-XSR receivers. I prefer an XM Plus because those have a bit of firmware that outputs the RSSI on one of the aux channels. With this, you have to do it through the Taranis, so I'm going to take a look at that as well. I am having to go back to my Taranis Plus for the telemetry because the Lua scripts on the X10S, they are very buggy and don't work very well, and I was really disappointed in that. But here we're going to be able to change our PIDs through the Taranis telemetry screen and lots of other stuff, which is cool. And of course, as always with FlexRC, you can go on their website and custom pick your components. They sell this as a DIY kit, and you can select the various different options. And they do actually sell a 3-inch propeller. I wish I'd picked some of those up. But anyways, let's get on to the build. So starting off with the XT30 connector, I'm going to tin up the positive and the negative. You can order one of these as part of the kit, and you also get a buzzer and a JST connector with the cable. So I'm just using the cable here, and I'm going to cut off the JST part, and then going to cut some of my own heat shrink to length and place those over the cables there, and then I'm going to use a candle lighter to shrink those down. Then I'm going to strip the end of those cables and tin them up, ready for soldering to the ESC board. Next, I am going to tin up the solder pads of the battery connector. I'm using a premium Hakko soldering iron here. And then I'm going to tin up the individual ESC pads, and I'll just speed that up so you don't have to watch it in slow motion. Next, I'm going to solder on the battery connector, so that's the positive going in there, and then the negative. I'm then going to take the long metal screws that you get in the HDL-RC stack kit and feed them through the frame, and then screw on the nylon standoff, so that's 4 of those that have gone in. Then I'm going to tension fit the ESC board over the top for now and screw the motors in. Now, as the motors are not directional, it doesn't matter which arm you put them on. I'm using all 4 of the screws, and they are the shortest screws that you get in the pack. So that is all of the motors that have gone in. Next, I'm going to cut the motor wires to length. Now, as these motors are designed for a 2-inch or 2.5-inch frame, you don't need to cut down the last wire, but it is just long enough. But for the rest of them, I'm just cutting them down slightly. Be very careful when doing that because they only just about reach. But if you solder all of the motors direct to each solder pad, then you don't have to change the direction in BL Heli Suite later, but it doesn't matter if you have to do that. Next, I'm going to tin all of those up. By the way, there's going to be a lot of cutting, stripping and tinning in this video, but that's just how builds go. I will speed this up for you so you don't have to watch it in slow motion. Then I'm going to solder up the motor wires, as I say, direct to the solder pads so they are in order. And again, I'll speed that up so you don't have to watch it in slow motion. Next, I'm going to tin up the flight controller, so lots of solder pads that we're going to be using here. So I've tinned up the one on the bottom, and that is going to be the TX3, and then I've just put the flight controller on top of the stack just to keep it in place while I tin up all of the other ones there. So there's various different things we're going to be tinning, so I'll just speed that up. Now I'm going to install the buzzer direct on the board because there is some holes to feed it through. So I'm just going to solder those up at the back there. And I made a mistake here. This is the connector for the receiver, and I pulled out the green wire, which is for the S-bus. I haven't used a R-XSR before, so it's actually the white wire that you have to pull, but I just swapped the pins over on the pin header at the end. So I'm just stripping all of those now. But yeah, it's the green wire that's the S-bus. Then I'm tinning all of those up there. So yeah, the R-XSR, it's meant to be used as like a redundancy receiver. So the wiring's weird. Anyway, this is the positive going in and the negative for the receiver, and what I thought was the S-bus. And then this is for the telemetry, which is going into the PPM solder pad there. So this is the VTX, and this is the video wire going in. So save the wires from the receiver because you can use them for the VTX. They're nice silicon wires. So that's actually the tramp protocol that was going in on the white wire, and then the black wire is the ground and the red wire is the VBAT. So I'm going to cut those to length. I'm going to leave the white one a little longer because it's got to reach a longer pad. I'm going to strip all of those off. So yeah, the white one's going to go into the TX3 or the UART3 underneath. So now I'm putting more of the nylon standoffs over the top there, and there's 4 of those to go in. And then I'm placing the flight controller over the top, and it just slots onto the pins over the top there. Then I'm cutting the camera wire to length, and then I'm going to strip those. Then I'm going to tin those up so we can solder them to the camera pads on the flight controller for the on-screen display. So that's the negative going in there, that's the camera signal, and then that is, I think it's 5 volt actually, out to the camera. Then I'm going to tin up the wires on the VTX, and they sit directly opposite on the flight controller, so you don't need to have them very long. So just tin all those up there. And that's the negative going in. That is the video out. And then that is the VBAT. And then that is the TX3 underneath for the tramp protocol. And then we've got some more standoffs to go over the top, and that is so the VTX can sit on the top of that, so that's the VTX going over the top now. Then we have some little tiny nuts that go over there too, so these are all M2, these are, so I'm just going to tighten them up there. Then I'm plugging the receiver in and putting the heat shrink over the top there. It's my own heat shrink, just using a candle lighter to shrink that down there. And then I'm putting the little UFL connector on there for the antenna. And then this is some double-sided sticky foam, and the receiver is just going to sit on the top there so I can access the bind button when it's all together. So getting these sides on was the trickiest part. You really have to put a lot of tension in, which I didn't really like, but I know people complain of these popping off, so they have made them even tighter, but it's difficult for the build. But there you go, you have to really struggle to put those on. Then I'm plugging the camera in, and I'm using a Phillips screwdriver and the screws included in the camera to screw that in there. And then these are the standoffs that are going in on the side, so there's 3 of those, and again it's nylon, so be very careful not to screw them in too tight. So this is the one at the back, and I fed the antenna underneath there, and then this is the last one at the bottom underneath there, just to give a little bit of strength. So I'm taking my own silicon battery mat and just putting that on there. I think this is from Banggood, if I recall, so the battery doesn't slip. Then I'm using the FlexRC battery strap, but it's a little bit too long, so I'm going to cut that to length there. And then I'm using some short cable ties for my antennas for the receiver, so those just fitting on top of the frame there. I'm going to cut those to length. And then I take some of my own heat shrink again and feed the antenna through there. And then that's the other side. I'm going to use a candle lighter on those as well. And on the other side. And just bend the antenna up there as well. So there is one more thing that I have done after that, and I've added a little cable tie around here for the antenna of the VTX. The little UFL connector is a little bit loose. It could probably do with a little bit of silicone on there as well, but this cable tie should do for now. I've also put the props on as well, although I wouldn't do that at this stage because we have to go into Betaflight and test the failsafe, etc. But yes, the propellers, the direction that they go on, it should always be the curve on the inside. So you can see there on the inside and there, and also on here as well. I get a lot of requests to try out the clean air mod, which is where you have the propellers going on the other side. The advantage is that it doesn't throw grass into your camera. The disadvantage that a lot of people don't talk about though is that it throws it instead into your flight controller and your USB connector. So I prefer not to do it, but some people say that it flies better. So to set up the Taranis and have the Lua scripts and telemetry and everything, you're going to want to have OpenTX version 2.2. And I've set a model up here, so if I go into the menu and page over, so I've called it the Komori. The model image I usually just have as TBS Discovery. And then if we come down here, we need the failsafe set to no pulses. And then I set it channel 1 to 8 for the lowest latency, and then of course you're gonna want to bind, and when you do press bind you want the telemetry version of channels 1 to 8. Then you plug your battery in while holding down the bind button and it will bind to the R-XSR. And then if you want to do Lua scripts, you're going to want to download the Betaflight Lua script and install it on the micro SD card in the scripts section, and to do that, you need to put both of the trims in on there and then switch it on. It'll go into bootloader mode. You can plug in your USB connector and you can do it that way, or you can take the SD card out there. So I'll just turn it back on there and go back to the model. So just come out of there, go into menu and then page over. So that's the first page. So if we go over to the inputs, now a lot of people say, why do you always use inputs on your Taranis and not just go straight to the mixer? And the R-XSR, as I mentioned earlier, doesn't have the RSSI going out on an aux channel, so you have to make it do that. So what I do is I set up my mode and arming and beep on a switch there. So just go in there, you can see I just type in mode and then select whichever switch I want. So for mode it's going to be this switch here. And then if we go all the way down, I've used channel 8 for RSSI, and this is why I use the inputs, because you can't select the source as RSSI if you don't use the inputs first. So if you go over to the mixer, it won't let you do it. So you have to put it as an input and then copy all of the modes to your mixer, and then on channel 8 you have the RSSI, and what that will do is it will take the RSSI sensor and output it as a PWM figure. It's just taken me some time to get used to this menu system again after all of the different transmitters. One thing that you do have to do though is you have to set the weight. So if we go down to channel 8 there and go into edit, you can see that the weight has to be 200 there and the offset minus 100 there as well. And then if I just exit out of there and then page back one, if we go down to the RSSI on there, the scale needs to be 100 as well. So yeah, a little bit tricky setting that up, which is why I prefer the XM Plus, but if you want to do telemetry then you have to do it in this way. So if we then page over all the way to, first of all we'll take a look at the sensors. So the first time you bind it, it won't pick up all of the sensors, and telemetry won't be set up on here either, because we need to go into Betaflight and enable it and put all our commands in, etc. But in order for the Taranis to pick up the RSSI, you need to discover the sensors, so you'll do that afterwards. And of course, in order to get the Lua script working, then you're going to want to page over again, and then where it says screen 1 under script, select BF Lua. And then if we exit out of there, a long press of the page button will get the PIDs on there. It's showing no telemetry at the moment because it's not turned on. And we also haven't set anything up in Betaflight, so we'll need to do that next. So here we are in the Betaflight configurator. You now have to download it from the GitHub website, and the first thing I would do in receiving this stack is to just upgrade it to the latest version of Betaflight, because as this is a kit you're going to have to do a full setup on it anyways. So the way to do that is select the target as Omnibus F4, select the latest version of Betaflight. I would do a full chip erase and I set the manual rate to 256. You then load the firmware online and then flash the firmware, and if you get a serial port error up the top here, then get the Zadig driver and reinstall the DFU driver, or install the correct one. Unplug the copter from the computer, very important that you do that, and then when you reconnect it and do all of this again and press flash, then it should be fine. Anyways, I've got the quadcopter plugged into the computer via a micro USB cable. I haven't got the battery plugged in yet. I've also taken the props off, that's important. You can see it says COM16 at the top there, so I'm going to press connect. Now, the first thing that we want to do if we are going to mess around with any resources for the telemetry is to take a copy of the dump, because if I mess anything up, you can just go ahead and copy all of this and we can correct anything that I've done. So if you copy this, then open up a text document and put that in there. But next, what we need to do is remap that PPM solder pad to a soft serial, and the way that you do that is I've already written it down here in this text document. So I'm going to copy this here all the way down to save, and what that's going to do is it's going to free up the PPM pad there to none. You can see, so if we copy all of that and then paste it in there, and that'll reboot. And then if we go back to the CLI and then paste this one in there, it's going to set the soft serial to B14, which is that PPM pad, and then type in save. Now it does depend here on what version of the R-XSR that you have. Sometimes you have to invert the telemetry pad, but as this is the latest revision of the R-XSR, then I don't need to do that. One thing that I did have to do though is I had to, in the CLI, I had to set S-bus inversion off because it was on out of there. So that would be set S-bus underscore inversion equals off, and then save. But I've already done that anyways, and that'll reset there. So once all of that is done, there, I'll reconnect to it and I'll take you through the setup in order to get it working. So I usually enable expert mode here. So if we go into the ports, so the UART1 is going to be for the serial RX for the receiver, and then the UART3, if we come over here, you're going to want to select tramp as the protocol so that we can go into the on-screen display and change our power and channel, etc. And then you can see here it says soft serial, and I've got SmartPort selected there. However, in order for the soft serial to appear here, you're going to have to go into configuration, and if we scroll down here, you're going to have to turn on soft serial. And just while I'm here, I'll take you through this page. So we have got D-Shot 600 selected, I've got motor stop off, I've got the digital idle speed at 6 so we don't get any flips of death. I've got the gyro and PID loop frequency at 4K. I've turned barometer off. I've put the craft name in there as Komori. And then for the receiver, for the R-XSR, we've got serial based receiver and S-bus down here, and there's no correction needed up here. Then we need to have telemetry switched on. Important, if you don't have this on, then it's just not going to feed it through. So just a very small thing that you can miss in order for the entire thing not to work. I have air mode on permanently, on-screen display, anti-gravity and dynamic filter, and if I come down here I just have the USB turned off on here as well. So if we go into power and battery, this is actually set at the default, but I'm going to reduce it down. But for the line of sight flight and the FPV flight, I kept it stock to see what the amp draw was like. But yeah, you want to bring that down to about 3 volts, I would say. I'm not going to save it. So if we go into the failsafe, usually don't have to touch anything here, but of course make sure that it works. So plug your battery in and arm it, even though we haven't put the modes in yet, so you can't really do that, so you do that afterwards. But arm it, turn your transmit off, and everything should stop. So if we go into PID tuning next, so these are some stock PIDs that I've put in. So usually with a very lightweight model you have to go low on the gains, so this was just stock PIDs here, so I've reduced the P down to 35 and 34 on here. And you tend to find with a squished X that you have to go up on the I gain on the pitch, so I've done that. I mean, this is all just guessing, and this isn't going to be a tuning video, it's just the info that I've put in there. And then on the D we've got 16, my super rate at 0.8, and then down here I've actually put anti-gravity gain on at 3 as well, just because it can suffer on the I, and I've upped the TPA a little bit as well, so that's throttle PID attenuation. So when you go up on the throttle it decreases the PIDs and that's everything that I have done in there. So the receiver tab, so the copter isn't plugged in at the moment and my transmitter is off, but as this is a Taranis that's set up as TAER, I've got that as the channel map, and you'll see the RSSI channel on as the AUX4. So what I'm going to do now is turn my Taranis on.
Welcome to OpenTX.
And before, when I set up the RSSI on channel 8, then if I plug the battery in, we should start to see that as a PWM value. So let me just plug a battery in here. So you should see on the AUX4, this is the RSSI here. And so that's why I've got it set to AUX4. So I just wanted to show you that. I'll just unplug the battery. And I haven't changed anything else on here, I don't think. So if we go into the modes, so I've got my arming on the AUX2 to match what I had in the Taranis earlier. And then I've got the mode here on the AUX1. I've just got angle over here for the Maiden, and then acro and F over here for anything else. I've got the beeper on the AUX3 over here, and I don't put turtle mode in or anything else. So if we go to the motors tab, as this is D-shot, then you don't need to do any sort of calibrating. However, as this is a fresh build, I would check the motor direction in here. So plug your battery in, tick this here, and then check the direction. It should go in this direction here. So this is motor 1, that one should go that way. You can just feel it with your fingers when it's going around, and then 2 and so on. And if any of them are in the wrong direction, we'll change that in BL-HALI-S in a moment. So next onto the on-screen display. I've got our RSSI value selected there, and then I've got the main battery voltage as well, and we've got timer 2, which is the flight time, and the fly mode, so you can see what mode I'm in, and the craft name, Komori there, and then VTX channel. I like to have this when you have a smart audio. I find it useful. It tells you the band here, and then it's also got the channel and also which power output you're on these numbers as well, so I like to have that. I haven't got anything else on here though. There's no current sensor on this board. It's the only thing that it's missing actually, and I could probably go ahead and remove some of these here, so like used milliamp and max current, etc., and speed, and I'll save that. And I put one more command into the CLI, and that is set small underscore angle equals 180, and then save. That is just so that in angle mode, if I get stuck in a tree or something like that, it'll still let me arm. So if you don't put that in, the copter will have to be pretty flat in order for it to arm there. So if I just connect back on there and then disconnect, because the next thing I'm going to do is just take you into BL-HALI. Now this is the Chrome configurator, which I don't think you can get anymore, so you'd have to download the standalone, but it's very similar. So what I'm going to do is just plug the battery in here, and then I'm going to connect and then press read setup. And this is running 16.5, so if you wanted to do D-shot commands, you'd want to do flash all and select the latest, but I'm not bothered about that because I've got a buzzer and I don't do turtle mode. So you can see everything is normal here, but if you had any motors running the wrong direction, then you would obviously select reverse here. You don't really need to touch anything here whatsoever. And that's about it for the setup. Okay, so now that everything is set up in Betaflight, the next thing to do is plug the battery into the copter and discover the new sensors that appear in the Taranis. I should say, though, at this point there's quite a lot of things that can catch you out, and it's one of the reasons why I don't like this system very much. The first thing that caught me out was the firmware on the receiver. The firmware the R-XSR came with does not support the PID tuning through Lua script, so I had to go onto the FreeSky website, download a version of the firmware that has fixed that problem. I think it was dated the 9th of October 2017. It was pretty easy to flash because in the package of the R-XSR they give you one of these spare JST connectors, and it's got a servo pin on the end, so you have to rewire that if you're using a Taranis Plus so that the ground and the voltage are the opposite way around, so that the positive is on the top there, so it goes positive, ground, and then signal. And then I uploaded the firmware onto the SD card and then externally flashed it. So that was the first thing that caught me out. The next thing that might catch you out, I'll plug the battery in here.
Telemetry lost.
She says telemetry lost. And if you try and discover the sensors when it's lost the telemetry, then it won't work. And the reason that that happens is if you got the transmitter too close to the copter, then they interfere with each other. So what you have to do is put the copter over the other side of the room.
Telemetry recovered.
So that can also catch you out, by the way, if you've discovered the new sensors and you go into the PID page and you'll get blank PIDs if they're too close because the telemetry is not working. But anyways, if I go into the menu and long press the page button twice, we go into the telemetry screen here, and then if we go down here you can see it's already discovered all of my sensors here. And then press discover new sensors and it'll list all of these sensors. But what you need to do then is turn off the Taranis and turn it back on. Otherwise, it won't update the sensors and you still won't get anything in the PID tuning page. So that's another way it can catch you out. So if we now long press the page button, you can see I now have my PIDs on there and I can go in and change them if I want. And if I press the menu button, we've got other things such as our rates that we can change and, you know, all sorts of other settings like that. So as you can see, it is working. It's a little bit of a pain to get going though. I'm not sure there is a huge benefit with it compared to going through the on-screen display and changing things that way. I think that's my preference. But if you are interested in doing this, then you know this is how you do it. Anyways, let's get and take this copter for a fly and see how it performs. Okay, let's go for the Maiden with this guy. The sun's come out. So I'm just in angle mode here to make sure everything's going the right direction and we have no major problems, and that seems to be fine. It's a little punch there just to make sure we don't have any flips, and then I usually do a longer punch. Blimey. This thing's crazy. Imagine what it'd do on a 4S and also on 3-inch props. Yeah, nice. Okay, let's try a bit of acro. It's nice and quiet with these 2.8-inch props. Oh yeah, very nice. This is nuts what you've come up with here, Dimitri, it really is. I like it. So I've got really low gains on here. For now I'm gonna have to tune it properly. But it's behaving at least for the line of sight. I like it. I actually haven't messed with the battery warning voltage and the beeper's not going off. Not yet anyway, so doesn't look like it's too crazy on the amps, which is good news. I'm finding that inverted, it's not hanging very well. I could probably increase the digital idle, but it's always a risk doing that. I like to run it higher than it needs to be really, just so we don't get those flips of death. Oh, this is a beauty. I need to practice line of sight more. But I don't want to bin it before I do FPV with it. Yeah, anyways, I think it's safe to say that it's past the maiden flight. So before I push it, stick it back into angle mode, and no drift there. That's fine because I'm just going to be flying this in acro anyways. But yeah, I like it. Let's come in for a landing.
Where do you go when you're young, when you're restless, when you're fun, 'cause you're desperate?